Hi guys, today in this video, I will explain how the SMPS power supply works. We will see what happens inside it, how it converts power so efficiently, and why it is used in almost every modern electronic device. By the end of this video, you will clearly understand the basic working principle behind switching power supplies. A switching power supply does not reduce voltage by wasting energy as heat. Instead, it rapidly turns electricity on and off at very high speed, breaking power into small packets. These packets are reshaped, filtered, and recombined, allowing efficient voltage control with minimal energy loss compared to traditional linear supplies. At the heart of a switching power supply is a fast electronic switch, usually a transistor. This switch turns on and off tens of thousands of times per second. By controlling how long the switch stays on, the supply precisely regulates how much energy moves forward in each cycle. Once power is chopped into high-frequency pulses, it passes through a compact transformer. Because the switching happens so fast, the transformer can be very small. It transfers energy efficiently while also providing electrical isolation between the input side and the output side of the power supply. After leaving the transformer, the pulsed energy is no longer usable as is. Diodes convert these pulses into one-directional flow, and capacitors smooth them out. This process turns rapid electrical bursts into steady DC power that electronic devices can safely use. To keep the output voltage stable, the power supply constantly measures itself. A feedback path sends information back to the switching controller. If the output rises or falls, the controller instantly adjusts the switching timing, maintaining steady voltage even when load conditions change. All of this happens inside a compact physical system. High-speed switches, magnetic components, and control circuits work together in tight space. By operating at high frequency, switching power supplies achieve small size, low heat, and high efficiency, which is why they dominate modern electronics. One major advantage of switching power supplies is heat reduction. Because energy is transferred efficiently rather than burned away, far less heat is produced. This allows smaller components, reduced cooling needs, and reliable operation even in tightly packed electronic systems. Compared to linear power supplies, switching designs adapt far better to changing conditions. They handle wide input voltages, varying loads, and modern energy demands with ease. This flexibility makes them ideal for chargers, computers, industrial systems, and almost every device that relies on efficient power conversion. Despite their advantages, switching power supplies introduce challenges. Rapid switching creates electrical noise that can interfere with nearby circuits. Engineers manage this using careful layout, shielding, and filtering. When designed correctly, these techniques keep interference low while preserving the efficiency benefits of high-speed switching. Another key reason switching power supplies dominate modern electronics is scalability. The same core principles apply whether powering a small phone charger or a large industrial system. By adjusting switching frequency, component size, and control logic, designers can scale power levels without changing the fundamental architecture. Reliability also depends on intelligent protection. Switching power supplies monitor current, voltage, and temperature continuously. If abnormal conditions appear, the system reacts instantly by limiting power or shutting down. These safeguards protect both the supply and the connected electronics from damage or failure. When viewed as a complete system, a switching power supply is not just a power converter. It is a tightly coordinated loop of sensing, control, and energy transfer. Every section responds to the others in real time, allowing stable operation across changing electrical and environmental conditions. This system-level behavior is what separates switching supplies from older designs. Instead of passively reacting, they actively manage energy flow. By constantly sensing and adjusting, the supply maintains efficiency, stability, and protection even as the connected device starts, stops, or suddenly changes demand. This active control is especially important in today's electronics, where power demand changes rapidly. Processors, radios, and motors draw energy in bursts. A switching power supply responds instantly, delivering power only when needed, reducing waste and ensuring stable operation under highly dynamic conditions. Because of this responsiveness, switching power supplies enable modern features like fast charging and compact adapters. They can deliver high power briefly, then back off instantly. This precise energy delivery improves efficiency, extends component life, and supports the demanding power profiles of today's electronic devices. At a deeper level, switching power supplies represent a shift in design philosophy. Instead of controlling voltage by resistance, they control time. By deciding when energy flows and when it stops, the system achieves precise regulation while keeping losses low and performance consistently high. Understanding this time-based control explains why switching power supplies dominate modern design. They adapt to change, minimize waste, and scale efficiently. From consumer electronics to industrial systems, this approach delivers reliable power while meeting the growing demand for compact, energy-efficient solutions. In the end, switching power supplies succeed because they treat energy as something to manage, not waste. By slicing power into control moments and shaping it precisely, they achieve efficiency, flexibility, and reliability. This is why nearly every modern electronic system depends on switching power technology. I hope this video helped you understand how switching power supplies actually work. If you enjoy such clear and practical explanations about electronics, make sure to subscribe to the channel. More informative sessions like this are coming soon, so stay connected and keep learning.